record. Um, we basically have a week and a half left of class. So next week, Tuesday, I will start having some of you give little presentations. And then Thursday will be the rest of you since I think we have 19 people. I will, if you drop me an email with your preference, I will take that first. Otherwise, probably by tomorrow, I will randomize you. Since this is the end of class, we will do it through Zoom. I can do a pre-recorded video if you would rather do that. I'll give you some details on what I'm looking for. It's not intended to be very stressful or a lot of effort, just show us where you're at. But what I wanted to really get across is that I put up your deliverables for your final assignment in Blackboard last night. Days are starting to blend together. And what I'd like for your deliverable, again, this isn't a full-on term project, it's a term project light. I've got it set to be due the Thursday of finals week. Now, this is not intended to stress you out that you should be working on it through finals week. This is to give you flexibility to wrap things up if you want to. Please feel free to turn it in on the 23rd, just so that you're done. But I know a lot of people in the past have liked to have a little bit of extra time just to get it where they want to be. It's after our final exam, and it's set to be the Thursday so that I can have time to grade it before grades are due. But just make sure that you get that in. Now, with this, since I have the deadline set so late, I know late submissions are possible. So if it's not in by here, it's not getting in. So just make sure that you get it done by, ideally by next Friday, but we have that. So what am I looking for this assignment for your, again, it's under term project here. Your code should be well commented. Basically, I want you to create an archive, so a zip file or a tar.gz and upload it to Blackboard. So give me your code. Give me a README file that describes what your project is, what graphics tools you have used. So like what libraries or what frameworks or, what did you do? Um, and then how do you install it and run it? So basically the README file should be an intro for somebody who, say, wants to check out what you're doing and be able to run it. Also would like screenshots or a recording of it working so that I can basically see what you were intending. So just take screenshots, take do a screen recording. If you're on Windows, you can just hit Windows G and get your screen recording bar. I know there's software that I'm sure all of you are familiar with. If you need help with this, let me know. But yeah, so basically just demonstrate it working. And then since everything's been web-based here, link me to where it's hosted at. If you're doing something that's not running on a web server, let me know in your README file that that's not possible. I know most of you are doing WebGL stuff for Unity, and if you're running it like on a web page, basically give me the link. If it's not feasible, that's fine. Yes, absolutely. That would work. Honestly, that would be preferable in a way because then it's long-term persistent for you all. Yep, that's fine. I mean, I've got all of my P5 stuff up on projects. I've got mine all up on GitHub. So this thing is now up here. Oh, it's even already going. Cool. But yeah, GitHub's fine. Any questions though? So again, you have until the end of finals week to really get it done, but that's more for your stress levels than anything. Get it done before finals and life will be better for you, I would guess anyway. Okay, so we have that. And again, next week, so basically the remaining classes that we've got, today we're gonna probably wrap up scripting and get started on 2D. Next time we'll get started on 2D and probably start talking about the shader graph. And that'll be our last thing that we really talk about. And then we'll go into your presentations. And probably tonight I will make that Unity assignment available as well. I told you it's pretty bare bones so that you can focus on getting your term project stuff done. Basically, it's just recreating what we're doing in class today, so it shouldn't be too stressful. But I know some of you would like to have Unity experience, so we have that. questions, comments, or concerns on the remaining classes or deliverables or anything like that? Closed Blackboard too quickly. Also have the Blender lab is due the 16th. Otherwise, we will continue on. What's the PogChamp for today? Is it still the Raptor? Still the Raptor. All right. And again, I'll drop an announcement with announcements as well, but we'll do next week on Zoom so that you can all do your chatting easily. All right. So, can I present and then Alt Tab and then get into that nice. How did I get into like half presenting mode? Because that's ideal. You go over here. You stop being full screen. F11? Yeah, there we go. Perfect. Okay. I'm gonna have to go back and forth between slides in Unity here, and I think hopefully they're all open. Good, good, good. All right. We ended up talking about inputs, right? We talked about get key down. We talked about updates and the various forms of updates. There's fixed update, late update. Basically, when do you want your update script to be called, right? So when do you want, okay, that's gonna get really annoying. Sorry about that. Outlook is now closed. No more bleeps. Basically, physics-based updates would go into fixed update. That way you know that it's going to be called every single particular instance. Late update is called at the very end when we just kind of group everybody's late update calls together. And then general updates kind of more sporadic, not necessarily guaranteed for a particular time. Right. We then, well, I guess for the rest of this little module here, we're going to be doing the ball roller. So if you want to follow along, you are more than welcome to. I absolutely love this demo because it really drops you into the deep end of Unity, gets you going with 3D, with velocities, with inputs, and it's really kind of a nice introduction to it. So we'll get into the, actually, sorry, we have sound and frame rate and then the ball roller. My mistake. One thing which you might want to consider is the frame rate of your applications as well. So you probably have heard the term 60 frames per second, 30 frames per second. That's just how quickly our applications are updating, right? So usually 30 is kind of accepted as, no, sorry, 24 is like what the human eye can register. And then anything above and beyond is just kind of smoothing out. It seems to be more or less 60 frames is the current big deal, right? So you can try to lock your applications to that frame rate by calling application.target frame rate. Now, the thing is that there is not a guarantee that you're getting this frame rate. Basically, you're telling Unity, try to do this, but be aware that if you are spawning 500 million polygons, this frame rate might not be achievable and you'll start seeing slowdown. So you're actually going to have to do some optimization if that's the case. But you want to make it run as fast as possible, set it as high as you want. So here's 300. Let's go super fast. Lock to 60. Okay, let's drop anything above 60. The other thing that you want here too with this frame rate is, okay, we're trying to guarantee a smooth animation or a smooth game. Also consider that we are trying to future-proof our applications. So I'm probably sure you know a lot of the older games that are out there. They would be bound to like the CPU cycles where it's made for that old target hardware. And if you try to run an old game on a current computer, it just goes blazing fast. And you have to do something to lock it down, like run it in compatibility mode or something like that. Frame rates help with that. So we basically try to lock to a particular timing cycle rather than as fast as the CPU can run it. Hopefully common knowledge now, but I'm going to guess not everybody knows that. And if you've, again, ever emulated an old game, like a 80s or 90s era PC game, like if you tried running the original Grand Theft Auto, which is my favorite one, runs really fast unless if you lock it down. Okay, so we have frame rates. We can tweak that. We also have sounds. Now sounds are actually pretty easy. So we're going to add on an audio component. We're going to drop a sound onto it, and then we can play it. So I'm going to go ahead and I created some new projects here, and I'm moving my presentation to the other screen so that I can see where I need to be at. So here I have a scene, 3D scene. I'm going to go ahead and add on, let's see, we'll just leave it as is. I need to add in, I downloaded a sound from, oh boy, where did I put it? Maybe it's just in my downloads. I'm doing it off screen so that nobody sees how bad my downloads folder is. Okay, I went to opengameart.com, which is a website you should all become aware of if you're not aware of it. Great for assets, by the way. Open source royalty-free assets. I grabbed a random sound and let's see. Let's drag this one on. All right, quick question. Can you all hear this when I play it? So I'm going to go ahead and try this. You should be able to hear it. Let me actually bump up my audio a bit. It looks like you should be getting it. Yep. Sorry if that was super loud. Okay, so I've got this audio component here. I just dragged it into my assets, by the way. You can import it in other ways. But here we actually see the waveform. That's good. Yeah, it's this Juhani Junkala. I have no idea. I just grabbed the first music pack I could find. But you can actually play around with the settings too, so you can show the audio decoder, sampling rates, quality, all this kind of fun audio stuff if you want to play around with that. But I have this in my application now. So I'm going to go ahead and let's go to our main camera. Audio listener. Interesting. Let's add an audio component. Oops, audio. Attach an audio. Oh, I've got to add a script. My bad. So I need a script too. So create. This is going to be a bigger project, so let's create a folder first. Scripts. Okay, go inside there. Create C# script. Let's call this player controller because this is future goals. And font size, I forgot to open up before class. All right, so I've got a script here, and let's drop in a sphere because we're going to need our sphere. Call you player. You need to have this script attached to you. So I drag the script onto the player. I see it down here. Now I'm going to go ahead and add on my audio component. So private audio source, audio data. Just following the slides off screen, by the way. Audio data equals get component audio source. Delightful. We have a reference to a script, or sorry, to our audio component, and I want to play it on a key up. So if input.get key up, key code.p, audio data.play 0. So basically I'm just saying play from the beginning. Let's try to format, and we'll see. I added a C# prettifier, so those of you that absolutely hate my tabbing before it gets fixed off camera, I grabbed this prettifier one, and I really dislike how it formats C# code, but that's how it's going to be for today. It looks like it's taking its sweet time making it pretty. Yeah, there we go. Sure, single line. Beautiful. So we have our script getting compiled. I swear Unity is a lot slower for me than it used to be. Now my script should have an audio source. Audio source, there it is. Me too. All right, so I added an audio source component. We see non-audio clip. I want to go ahead and drag my clip onto there. I love this like drag and drop things around in Unity, by the way. It makes things so much easier. And right here, it's play on awake. So once I click play up here, my clip should go. How about that? So that's the equivalent of going to a MySpace website in the mid 2000s and having your terrible band's music automatically play. So I'm going to click play on awake and deselect that. And what should happen, if I haven't screwed anything up, is we should be able to play it once I hit the P key. Perfect. Guess that's the POG key, as the children say these days. All right. Audio, pretty easy. You can play around with any kinds of like panning, stereo versus mono, volume, all that fun stuff to give your scene life. And I will say there are lots of things out there, I guess frameworks that you can import to do more like dynamic sounding type things. So if you want to register that there's an enemy to your right and you play the footsteps in your right headset can or something like that. There's also, I should mention too, I don't know if any of you have ever seen Fmod's logo pop up in various games that you play. Like it's front and center in Spelunky 2 whenever I load it up. This went open source, or not, maybe not open source, but it went free to use recently. So if you want to, ooh, generative music in here. I'll have to check this out. Basically, if you want to compose music for your games, this thing is now free to use. And maybe it's for hobbyists or I don't remember what the licensing scheme was, but basically you get superpowers over your audio for your applications. So definitely worth checking out if you want to go deep into the audio realm. But straightforward. Let's go ahead now and run through the ball roller. So obligatory professor GIF, as we obviously need to have. Like I said, I love this tutorial. If you've never done Unity before, it gets you really going quickly in 3D space. And if you're not a 3D person, it's a nice introduction to that. You also get prefabs, you get text, UI elements, you get velocities and colliders and physics, and it's pretty straightforward. Here's the link to the tutorial if you want to play along. I'm going to basically run through it in kind of speed mode. Obviously, if you read through the tutorial, you get a ton of detail about every single step. I'm just going to show you it actually working. But what we're going to do here is we're basically going to do a little collectible type of game. So we're going to have the player be a ball. The ball can roll around. So we're basically going to use sphere-based physics. We are going to have all these little cubes instantiated on screen. They're going to spin around. We'll give them everything in material. We're going to be dealing with lighting, with camera movements, with interaction with the environment. Again, a lot of things here. And you also see a little score right there. So we'll have that as well. So what do we have to do? To make a ball roll, and I think I actually think I said I still have it up. So this is the finished version. And if I forget when I'm done with this, remind me, I want to show you how to export too, because that's kind of a cool feature I find anyway. All right, let's go Unity. Come on, Unity. Now you can do it. There's nothing here that should be that full of effort. So this is kind of the goal, right? So something like this. We see the camera is following the ball very smoothly. Is it made with Unity? I can't tell either. So we see bouncing off walls happen, we see collection happening, we see our score incrementing. Because I'm exporting to WebGL, I can click full screen and we can make it nice and pretty. But we have that. And then, there we go, you win. So we have the floor, we have the walls, this is our environment. We're going to have the player be a sphere, we're going to make objects to pick up, and we're going to track a score. Simple game, a lot of moving pieces. So first things first, we need a 3D project. When we talk about 2D, we're going to see some of the differences between them. Basically, when you go to create a new Unity project, it just instantiates what you're going to be picking a lot easier and what like the camera is going to be 2D instead of a 3D camera. We'll get into what all these other ones are too later on. So I'm going to move this off screen now so that I can follow along a little bit easier. But we need a plane, we need a player, and we need some colors. So I'm going to talk through this as we go. But if you want these slides, feel free to open it up. They should be in Blackboard. All right, so let's, we'll leave I'm going to comment this out for now. So we're still just going to use this player object. Alrighty, back to Unity. Okay, make this a little bit smaller, please, please, please. No, fair enough. Are we just frozen now? F. Oh, I'm in game mode. I'm an idiot. It's been said before. Okay. Still, you should be getting smaller. I guess we don't want to do that today. All right, first things first, we need a plane. So I'm going to actually hide my player for now. So I'm going to select player, uncheck him. I am no longer enabled. So this player doesn't exist. If I hit play, my scene renders. I hit P. I don't hear any music. My player doesn't exist for all intents and purposes. So, game object, 3D object, plane. Here's our plane. How delightful. Okay. One thing with the plane is that scaling in the Y direction doesn't do anything. It just kind of makes it invisible or not invisible. We don't have a real dimension for Y. Okay, we only have X and Z. So I just left it as 1. But we could say stretch out X, we could stretch out Z. I'm going to leave them as 1 for now. But what we do get with the plane is we get a mesh collider. So you see that over here. Basically, this becomes something that we can collide with. So if I had my player back in, player, let's, I don't know why we're in this mode. I must have hit something. Shit. Oh, I'm in the wrong mode. How do I get out of transform or rotate mode? T? R? F? This is gonna scale. I want to move. Ah, crap. I'm in the wrong thing. I've got the wrong thing selected, and I don't know how to get out of it. Buttons on the top left. Thank you. Thank you, thank you, thank you. I love Unity. I really do. Just not super good with it. Okay, so the buttons that are right there. Yeah, click on the hands. This is the guy teaching us Unity? Oh, jeez. All right, so if I hit play, nothing's going to happen, right? We don't have a rigid body on this currently, so let's add that on. Rigid body, use gravity. Take forever to build. Perfect. All right. Now, again, I showed you this before, right? Where we can tilt our plane and we get this nice physics automatically applied by default. It must be out of scope here or something. But we have physics, which is good. Save our scene. All right. So this is our delightful ball. We have a rigid body. We've already named it to be the player. The plane, let's call the game area. Sure, game area works. I'm going to leave it up high. So I've got my player. Let's make a nice even number 2. In the slides, I've set it to 0.5, but it's just going to drop from a higher height instead of a lower height. So we'll leave it as is. Basically, this is where we're at. Yeah. So we see our sphere collider. It's not a trigger. Basically, we're not doing anything with the collider. Should mention colliders are something that are useful to talk about too. We'll get into that when we do the prefabs and the pickups and all that. With your objects, you can define something called a collider. Basically, if that collider gets touched or breached, you trigger a function of your choosing. Well, not of your choosing. There are baked in Unity functions for that. But that would be, say, if I collide with a coin, trigger the increased score, play a little bloopy noise to make it seem like you're actually, winning. But that is our ball. Looks nice and pretty. Let's go ahead and add a material now. So I'm going to, let's do this properly so I don't give you any bad habits. Materials, create, matte. Let's do teal. Let's do teal and actually pick it. Okay. Metallic, sure. We kind of did this last time, right? So nice. Let's not make the obvious joke. Let's go green. We have a nice green ball. Perfect. Okay. I could also go ahead and add on an asset too, right? So I've got a green ball. Yeah. We still have our music, I think. No, I commented it out. That's right. I could also do my import, right? So we did this before. Package manager. Let's make our ball super cool looking. Packages my assets. Free metal materials, and let's import one of these. Let's pick one at random. I feel like Unity was a lot faster with the 2019 version. This is gut instinct, but I feel like I don't remember all of these little menus. Let's do... Sure, let's do pattern 5. That sounds good. Pattern 5, import. I think it's getting bloated. I would agree with that. Pattern 5, diffuse. Nice. I mean, I like the idea of moving the asset manager to an external source so that you don't have that horrible in-app browser thing they had going on. But yeah, I just feel like it's gotten slower. Or is it this one that I want? Yeah, let's go with that one. I put the diffuse pattern on. All right, so we have our textured ball. If we run it, it should drop nicely. And we should see our pattern kind of appear. We don't have any rotation, so it's just going to sit there in space. Yeah, I've heard Unreal is a bit bloated. All right, so this is what we would have if we went through pattern 6, apparently. We'll do pattern 5. Let's also throw a material, let's, this one. Let's make our surface green. All right, so now we have to update our player controller. So what I've got in the slides is that I'm adding on a script and attaching it to the player. I did that already. So we can just go ahead and update our script as is. So let's add a rigid body reference. So private, rigid, lowercase. I always think it's uppercase. Let's get a reference to it, get components, rigid body, up, Control Alt F, and why not add on extra spaces? No, thank you. So now we have a reference to that. You can do something nice like see if audio data is null, then throw an error. If RB is null, throw an error because your front-end developer screwed up and forgot to drag that component onto it. I think we do that when we go through the 2D stuff. So we have a reference to our body. Now let's go ahead and add on a fixed update. So fixed update, again, this is for physics stuff. Doing too much JavaScript, we need that on the next line. Apply forces from inputs. So I'm just going to truncate this. Float, move horizontal, input.get axis horizontal, move vertical. Okay. So again, we have pre-named inputs in Unity. If you go into those project settings and then input manager, you can see what all those names are. I'm just getting them directly by what it's called. So this is going to be your joystick. It would be your arrow keys. I think it also works for the WADS keys as well. So we'll check that out. So movement equals vector3, move horizontal, move vertical. And then let's add this force to our rigid body. So what we're doing here, just to explain, get the force coming in from the whichever direction you're pushing, create a vector3. Should sound familiar from the WebGL days, right? So we're getting move in the X direction, move in the Z direction, not moving in the Y direction, and then just add that force on to your rigid body. Basically, we're going to do a matrix math, or a matrix multiplication to just kind of add a velocity to our ball. And since it's a fixed update, this is going to be our guaranteed update every cycle. Let's compile and play one of these years, hopefully soon. There we go. Ball drops, arrow keys, we see movement. Look at that. And I'm just holding my various keys. Now, do the WADS keys work? Yes, they do. Cool. I can never remember how the various engines map their keys, but I could throw a joystick on here and it would work just as well. And then we fall off the world because we're making Marble Madness. All right, so that is our fixed update. What we can do now too is add on a speed, so that's kind of slow. Let's add a public float speed. Mouse out of the way. Fixed update applies every frame. Yes, it's every tick, and it's guaranteed at a specific time. Yes, tick is just like a quote-unquote time reference unit. So we're going to call our speed, and we're going to say movement times equals speed. All right, so by making this thing public, well, that's the thing though. So yes, it does tank. If it tanks, it's still going. It's just basically, it's getting called slower is what happens. So that's why if you start seeing slowdown, your update cycles are still getting called. They're just running super slow because you have so much going on. But stuff like what Unity is doing, it tries to optimize all of the calls, does a lot of nice algorithms and data structures behind the scenes. Probably lots of trees and mapping and all kinds of fun stuff. So I defined a public float. I didn't initialize it, kind of intentionally, because I'm actually going to see now this pop up in my editor here. So where's my script? I think I just went by it. Here we go. Speed is 0. Let's make this 10. You can initialize it and start as well if you want. So I set it to 10. Looks like it's moving a little bit faster. Let me set it to 1 before we run off the screen. No, 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 no. Let's make our playfield a little bit bigger. Let's go 3 by 3 in scale. Knew that was going to happen. All right. Player. Speed is 10. Okay, looks like we're going pretty fast. Set you to 1. You're a lot slower. You can feel a lot more mass behind the scenes here. Set it to 100. Whee! It's just a multiplier for that movement force. Basically, your vector is getting multiplied here. Okay, so we have a ball that we can move around. Easy peasy. Took me literally one calculation to get this done, and I'm really not doing anything here. right? We are getting a force input from the controller from Unity. So I don't have to figure out like exactly how hard I'm pushing the joystick. Unity's just giving me a scaled value for that. And we are just tacking it onto a physics-based calculation with a rigid body. Okay, so we have that. Now let's play around with our camera. Obligatory unsplash image camera. So first and foremost, let's position our camera. So we want our camera here, and we can see what we're looking at. Let's move it up by 10. So let's go to Y is 10. Let's rotate it a bit around the x-axis so that we can look down. Scale is still fine. And if we update now, we're going to be super zoomed out because we moved the camera up. But we can see our playfield better, right? Still would be nicer if, we could actually follow the ball. So what is, did it remember 10? Okay, it did remember 10. I would say make sure you initialize your variables. I did not. Let me go ahead and fix that because it's going to bother me otherwise. Speed equals 10. I need a prettifier that lines up the equal signs because this is going to drive me nuts. There we go. That's how it should look. All right, done auto formatting for today. But we want to follow the ball around, right? Why did you hit save? You knew it was going to do that. So if you want to have a camera follow an object in WebGL proper, it sucks. You have to do all the calculations by hand. Here I can just drag the camera to be a child of the player. We're going to see an issue though. Should be pretty clear why. Whee! Not necessarily a good thing. So what we can do is script it out a little bit. So I'm going to undo making the camera a child. I'm getting nauseous. Hey, it would be great for a flight simulator though, right? So what we want to do, so I unparent or I unchilded it. We're going to add a script for our camera now. And I'm going to start copying and pasting code so that we go a little bit quicker. Camera controller. All right, so we have our camera. We got to get out of presentation mode over here so I can select. What we want is something like this. So I'm going to get rid of all this stuff inside. Move our mouse. I guess we'll auto format. God, really? Ugh. Okay, prettifier, you suck for C#. So this is some camera code that is, again, off the Unity site, but we have a start function and a late update function. Basically, we are going to run this at the end of our update cycles. So this is, if you remember, helpful for avoiding jitter, basically running after your physics calls are happening. So we're getting a reference to our player. We're creating an offset. And we're just calculating an offset from our player to our current position. So transform.position would be our camera's position. And then we're going to get an offset from where the player currently is. Yes, Natalie, if you have a formatting plugin for your Visual Studio Code, I would love it because I probably looked for 10 minutes and I had no idea which one was going to be good and I didn't want to install them. I know you do this for a living, so please feel free to suggest. So we're going to do this when we initialize. Then every frame at the end of it, we're going to take the player's current position at our offset, and that's our camera's position. Looking right now. There's a lot of them. I'm kind of surprised. So we have that. Go ahead and compile. Sure. Go ahead and compile. And compile. All right. Add this to our camera. Save. We now have a script attached to our camera. We need a reference to our player object there, right? Because we made this a public reference. So drag to player to here. Now we have a reference to our player. If I didn't do that, we'd get a null reference error. But our camera now nicely follows our player around. And it does that based on its initial position. So we can now fall off the map forever and we'll just kind of follow our ball. Any questions on this part? I know this is probably basic for those of you that have done Unity before, but there's a lot of little things here. Like, you need a different mode of thinking for how a framework like this works. You know, I haven't let it run for too long. I don't think, if you roll over the integer memory space, you might have an issue. So if you get to the end of your 64-bit, I mean, you generally want to limit it, sure. I assume there's a bottom. I've never found it, but not necessarily something I want to do on camera because my guess is we'll be sitting there for a while. I mean, we could, let's do this just for the hell of it. Update debug.log. Sorry, I think it's capital. This.position. I think we should be able to do this. Oh no, what have I done? Nope. Position. What is it called? Transform.position. Oh, transform.position. My bad. I'm not going to let this run forever. I just want to see how far it can get while I move to the next slide. Player controller does not contain a reference. Okay, yeah, okay, there we go. So if we go to console, there we go. Here's our position. Move, please. So here we go. All right, so we have a moving camera. We see things happening. That's going to take its time. What we're going to do next is add some walls so that this can't ever happen again. Yeah, it's going to take way too long to wait. So let's get rid of this. That's going to compile. What we're going to do now is add on some walls. And this brings into the project the idea of game objects that are empty. So basically here we can create a folder. So create empty. We'll call this walls. Walls we want to reset to the origin, which looks like that's not here anymore. Or no, it's right here. So this is kind of important, by the way. So if you're adding on new objects, you want them to be, so you see transform, there's these three little dots here. Click reset, that brings them to the origin of your project. That way you're referencing everything inside of here from this point. Because before I had the ball selected, and that's where everything was. So when you see reset in the slides, that's what I mean, transform, reset. So let's add on a wall. Add on a cube. We'll call this wall 1. And we're going to say this is at -10, 0, 0. And we want it to be 0.5 to 20.5. All right, so this is wall 1. We can make our, yeah, we'll make it scaled nicely there too. So if I frame that in, here's a wall. See, it kind of extends, and you could play around with this as much as you want, obviously, right? But what we're going to do now is I want this inside of walls, and I'm going to duplicate it. So I hit Control D. We'll call this wall 2. I could make this a prefab as well. I do know that. Scale's fine, but I want this at +10. So now I have 2 walls. Hooray. And now I want a third wall. Duplicate. F2. Wall 3. Intentionally not naming it wall east, west, north, south, because I don't want to figure out what that is. You're at x0, but z of 10. Your scale is 20.5 in x and 0.5 in z. And there's my third wall. And now wall 4, it's going to be the opposite. So you are at -10. And now we have 4 walls. How nice. Let's see here. So we have that. We have our walls. I'm gonna go ahead and hit play. Look at that. We are now bounded. And you can add on like bounciness too with your ball to have it react off the walls. I'm just gonna have it kind of slush towards that wall. But this is, again, all in the slides. We could go ahead and let's add on a metal texture. So let's add on, I guess we have to import a new one. This is why you import what you are going to need. Come on. Come on. No more falling. So what we're going to be doing next is adding on our collectibles while we're waiting for this. So let's do, what's 11? Sure, we'll do 11. Again, I just grabbed this as a free asset off the asset store. All right, so pattern 11. I want the metal. It's probably an easier way to, can I just do this? Nope, thought I could. If I made these prefabs, it would work, but exactly. There is a absolutely delightful NSP song. It's like they're a metal song, and it's a bloopy little jazz tune. It's great. Anyway, we see a nice texture here. Ooh, how delightful. If we hit play, we can see this in action. We are now officially out of coffee. It's a disaster. Perfect game board. So we have that. Now let's add on some collectibles. What we're going to be doing here is creating prefabs. Now, prefabs are something which are going to be very, 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 very useful to you if you're making anything where you need to instantiate a bunch of objects. Basically, you make one object, and then you just create copies of it. And this is going to be a prefab. The prefabs will continue on with, or they will have their own instance of scripts, of materials, of all that fun stuff. But you'll see as we go along. So I'm gonna save this now. I'm gonna hide my player again. And this is also just as a warning where I always will screw something up too. Just as fair warning. I usually misclick here in some way, shape, or form. But we have a new cube, so this will be our pickup. Actually, no, can we do... Let's do a cylinder. Cylinders are more fun. Let's make it a little bit smaller. Okay. Let's do 0.25. And let's give you the same pattern. Why not? Very shiny. Oh, it makes everything like that. Makes sense, because I'm just modifying the texture. All right, so we have our pickup here. And let's call it collect. That's not what I wanted. Collectible. So we have that. We want to reset it to the origin. So transform reset. We see it down here now. That actually screwed up my scale. So we want this to be 0.25. I want you up by a half. Let's see. We above the frame. Okay. Let's make you a little bit smaller. 0.15. I'm deviating now from the slides. And we're going to rotate you by 45 in all axes. Okay, so it's kind of like that. Neato burrito. Add a new script. We'll call this collectible controller. And we want you on the collectible. Okay. So we do not need start for this one. Nothing to instantiate, so we can just get rid of it. Just leave it as update. And what we're going to do here is let's add on a rotator. So transform.rotate, new vector, wow, I can type today, 15, 30, 45 times time dot delta time. Excuse me. Rotate here is going to do automatic interpolation for us too, so it's going to be a nice smooth rotation. So what happens when I hit play now is we should see a little rotating cylinder. All right, so we're going to hit play. This might, okay, good, it does work. So rotation's happening. Let's add our player back in. Actually, no, player stays out for now. We want to make this a prefab. So I'm going to create a folder called prefabs. Oh, I call it pickups in the slides, not collectible. But I'm going to drag this object into prefabs. And we see it down here now. So we're going to hit the top-down view. I'm going to get rid of this guy. And we're going to place some. Okay. So if I add in a bunch of these, I'm just hitting Control D and kind of moving them around. Maybe over here, over here. Looks like one over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do one more. Oh, why am I counting? They're right here. All right, so we have 3 of them, or 3 of them, 10 of them. All right, we are in global mode, so this is something that is helpful for you. Again, hitting that reset on the transform means that when I drag and drop them around, I am moving them in reference to the global position. If I hadn't done that and my origin was different, it would be kind of like rotated and moving them around in space really wonkily. But if I hit play now, I see a bunch of objects. Now, yes, they are all rotating at the same frequency, the same exact motion. In your script, you would probably wobble it a little bit, or you'd have the time be updated randomly or something like that so that they're not all perfectly identical motions. But it's fine. Let's add our player back in now, and we can kind of see what's going on here. Blink. So we have this, and now I can bump into them and I can actually roll over them, which is kind of a cool feature here. Simply by being cylinders or capsules or any of those basic 3D primitives that we have, they get a basic collider on them. So in reality, we have baked in physics here. We're going to turn that off on our prefabs, and we're going to turn it into a collider. Well, not turn it, we're going to use the collider, basically. But we have objects, which is kind of neat. Very little effort, I just filled up my scene with identical copies of the same thing. So now let's enable some pickups to happen. All right, so I want to, and I can also do something like this. Let me create an empty, let's do pickups. So let's organize our scene a bit here. So I'm going to move all these collectibles into this object. And again, empty game objects are basically just folders. Make aggregating things nice here. Okay, so we want our player's sphere collider. We want to toggle is trigger. So this is going to allow us to use the player's collider. Actually, sorry, no, we don't want that. This is where I start screwing things up. We want to make use of the collider without having it be a trigger. One thing that's helpful, though, is these little question marks that you see in Unity. It takes you right to the reference for whatever you want to deal with here. So like here's a sphere collider, audio source. This would take me to audio source. So just kind of helpful if you want to play with that. So let's go ahead and add on to our player controller, void on trigger enter, collider other. This is something that's going to be common with a lot of programming frameworks. You're going to have a callback function that gets triggered whenever your collider gets interacted with. And what's going to get passed in is the other object that you touched. So this is my player. If I touch a cylinder, it's going to be called other. So we want to not do that. We want to, over here, please, deactivate, but not destroy other. So we just want to turn off that collectible. So we will leave that there. What we're going to do here, and actually let me bring this back over so that I can show you what I'm talking about. So we're doing our sphere collider, right? One of the other things that is very important in Unity and most frameworks is the ability to tag objects. This gives us a very easy way to look up things that we're touching. So if I have a scene with hundreds of objects, I don't want to go through and say if object.name equals player or .pickup1 or .pickup2. I just want to label them all as a thing. So here I'd say, if the tag is a coin or a pickup or a collectible, pick up your coin and bleep a noise. I don't have to check every single specific object. I can just kind of group them in a category. We're going to do that with something called pickup here. So we're going to say, you back over here, please. If other.gameObject dot compare tag. I'm going to leave it as this spaced out thing just to demonstrate this is just a simple string. Other.gameObject dot set active false. So turn it off, hide it. Now, this is if a collision occurs. We're going to now open up our prefab. So down here, we see our prefab. So I'm going to double click it. And I just see the object, right? So here's my collectible. I need to add a tag. And you see here, tag. Right now it's untagged. We get some kind of basic default tags that that Unity thinks you might want. I'm going to add on a custom one. So we'll say pickup. All right. And our collectible, we're going to say pickup. And now when I go back to my scene, I'm going to click my pickups here. We should see pickup on all of them, right? Because I updated the prefab, which now applied it to every single other instance of this particular object. So let's go ahead and test this out here. This will not work, by the way, at this point. And there's a specific reason why. So we're still bumping into things. And the reason why that's the case is that our capsules, our cylinders here are still physical objects, right? We are going to be bouncing off of physical objects. And now what we want to do is pick the prefab and make it a trigger. So with that, we also want to make sure it's a rigid body so that we still have physics calculations. The thing under the scene here is that if it's a static collider, it's fine. If we're rotating it, these calculations are always going to be happening. We want our object to be dynamic in nature, is kind of what we're getting at here. If we don't have a rigid body, it's not going to work. So what we're going to do here is let's go back and do our prefab. Okay, we want to go to its collider. It's now a trigger, but we also need a rigid body. So I'm going to add on rigid body. And now that should be good, except, well, I'll show you. If I hit play, I'm fairly certain they're just going to drop through space. Yeah, because gravity is applied to them. So now we just turn off is gravity. But it needs to be, or sorry, gravity is fine. We want it to be kinematic. By clicking this little kinematic box, we're telling it to not react to any of the physics forces that we are imparting here, including collisions. So if I roll around, I should, yep, I'm not bouncing off them anymore, and I'm just picking them up. So my collider's triggering. When I call, on trigger enter, deactivate the thing that I'm colliding with. Questions so far? So key things here. Our player, we didn't touch the rigid body, we didn't touch the trigger, we just added a script for interacting. The prefabs, to make them not interactable with physics forces, we made them a trigger object and kinematic. And that goes into the physics calculations aspect of it. All right, we should have time to get through the scores now. All right, insert other unsplash image. I agree, I love it too. I really need to remember to get that project up and running. So what I did, just as kind of a fun thing, I don't have it running right now, and it's going to take me a hot minute to get it up and running. But pretend this is a Raspberry Pi, my phone here. Actually, I probably could do an Android app. I had a Raspberry Pi with a hat, a Sense hat on top of it, which has a gimbal or like an accelerometer on it. I was rotating it around, and it was rotating the plane. How can you export the score to the rest of the website, i.e. outside of the WebGL frame? That is a really good question. I don't know in Unity. I'm sure it is possible since it's just a web page. My guess would be that you can interact with the DOM with Unity. I'm not sure offhand. Unity update DOM. Really? Try Google. Unity. WebGL. Update DOM. Interacting with browser. Okay, so it is possible. Oh yeah, and I have never, no, I won't be covering it. Yeah, it looks like you can probably export JavaScript calls or something like that. It's possible, I guess, is the takeaway. I can see why you'd want to do it though, absolutely. So let's add a score. So let's stop playing here, go back, hide pickups. Okay, yeah, it's possible. Honestly, that's something that I'm doing with my little demo-y project, because let's leverage the browser, absolutely. Let me show the other people here what I'm talking about. Because if we, so this is, pretend this is a WebGL canvas, right? So this is just a normal browser canvas. This is a div, and I'm updating the div with information. Why not use the browser's, text formatting capabilities if you can? I absolutely love that point, by the way. So let's add a score. We need a score variable. So let's call it private int score. Score equals 0. Format manually. Every time we pick up an object, we increment our score. All right, so we set it equal to 0. In our onTrigger enter function, if we collide with an object, score plus plus. Delightful. We now have a score. It's private, so we won't see it in the in Unity. We could make it public. I want to kind of get through this before the day is done, so I won't do that. Although I probably had time with this compiling. But that will get incremented. What we're going to need is a canvas UI element. And this makes things a little bit different in Unity. So I'm going to go ahead and add a UI text. And we'll call this score display score. This adds a canvas element. And what you see, if you zoom way out, you get a 2D plane. And if you go ahead and play this, It's going to do like a weird interpolation between 2D and 3D, but you get a, let me go over here. Basically, it's going to treat your window as its 2D canvas for drawing. So here's my text. So the points of reference will be different. So we added that, we get a canvas, we get a text element. Technically it's a rect now. We want to do some tricky things, so we want to anchor it. So I'm going to click this positioning. I'm going to also set pivot, set position, so I'm holding Shift and Alt, picking the top left corner. Our text has disappeared. It is now up here. So basically I'm anchoring my text to the top instead of the bottom. And I'm going to give it some breathing room. So I'm going to make the X position 10, the Y negative 10. It's going down. Z is 0. And now what I'm going to see when I hit play is my text will be at the top left. So there's my new text. Okay. Now we need references to that, and we're going to add it to our player script. So we need a public reference to that element. So we'll call it count text. Just follow the slides. And we want to set count text equals score plus, what do I call it? Score dot toString. I can never remember my C# versus Python versus Java versus JavaScript string formatting. And that throws off our equal sign formatting, so we'll give you a new line. All right, so we initialize that. I don't want to Alt-Tab because that'll compile. Update we don't really need anymore, so let's just get rid of this. So this is going to initialize our text box to score 0. And then every time we increment our score, let's update that. Yeah, let's make this function. Void update text, string s. Count text equals s. It's probably a better way to do it. Then we'll just say update text, that, and that. And we will, nope, we don't even want that. We just want this. And we'll do the same thing down here. So super quick typing. Hopefully I didn't screw anything up. I just made a function call to make this easier. Every time we call start or when we collide with an object, let's update our text box with a string. And honestly, I could even, we don't even need that as a parameter. We'll change it later on. So that and that. We need to go ahead and text could be found. Oh, I'm missing a, yes, okay. I'm missing the reference. So we also need, oops, unityengine.ui, because I have to import that namespace. Console clear, because that should be fine. Our player now needs a reference to that. Oh, it didn't work. Did I screw something up here? Is it just lowercase string? My C# foo is way out of date. Yeah, that worked. Okay. So player script, we need a reference to our text box, so we drag that into there. We hit play and we should see score 0. 5 minutes left. We can make it. Score 0. Looks terrible, but that's fine. If I collide with an object, score 1, 2, 3, 4. Look at that, it works. Hot diggity. All right, zoom in. We have that. Okay, sure, let's add a win condition and then we'll end for today. So I'm going to skip the add another element bit in the slides. I'm just going to go ahead and say in our player controller here, if score is greater than or equal to, what did I say, we have 10? Let's do this. If score is greater than or equal to 10, let's do that, else, update text. Okay, update text, you win. Exclamation 111 exclamation, as is tradition. We'll make the I a 1. And we will do audio data.play. All right. So if we get all of our objects, we should get a win condition. Probably should have made it a lot less objects to pick up. Pop up. So 1, 2. And you can do cute things too if you're making a game off of this. Randomize the positions. So just on their init. Worked on the first try. How about that? One thing you might notice, text is tiny. Success noise. Implement success noise now. So the text is tiny. That's one issue. That has to do with our canvas, and that's drawing to its render mode. So we're going to say scale with, oops, nope. We want canvas scaler. Right now it's constant. Let's scale with the screen size. And we can set our reference resolution to be a lot smaller. So if I hit game, we can play with the size. Can make that like way bigger. Basically what I'm doing here is I'm just kind of playing with not necessarily the font size, but its scale factor. And I'm saying your resolution is a lot smaller. Render the rectangle for text to be related to that. So in this case, smaller is actually bigger text. So I hit scale with screen size, made the resolution tiny, and there's our lovely game. 2 minutes left. One thing that we can do, and hopefully this won't, yeah, I didn't get set up for this. We'll see. So I've got this nice ball roller game, right? Looks awesome, even has sound. You win, huzzah. If I hit save, one of the really cool things which I like about Unity, as long as it works, I can hit build settings. Here's all the platforms I can export this project to with minimal fuss. PC, Mac, and Linux, Universal Windows, WebGL, tvOS, PS4, PS5, Expo, and Android. You need to have the build chain installed. I already did this for WebGL, which is good. So let me try to build this right now. Yes, you do. And it does take up space. Like if you've ever gone through the Android build chains, you probably know you have to install gigabytes worth of stuff. I don't know how long this is going to take to swap over to WebGL. There are some gotchas with WebGL exporting too. As should be evidenced, I'm not a Unity expert, so I can't speak to all of them. But you may notice some wonky behaviors if you export to the web. This project should be fine, but once you start getting more complicated, you run into things like caching errors, which is problematic. Browser can only handle so much memory. Also ties in with your web servers that you're running because you will need a web server running this. So let me get a, let me build this. Actually, 5:15. I'm not going to hold anybody here. If you want to bow out, you're more than welcome to. I'm going to try to export this really quickly, and we'll see. But other than that, I hope you had a great class. I will see you all next time, but come on. Please go. There we go. Okay, build. Class 3D ball. Sure, let's make a build folder. Build. Pick that one. Oh, I might be able to build and run. All right, no, I hit build. Okay. Shit, this might take too long. Terminal. Docs, CD, GVSU. Where'd I put this? No. Unity. CD class 3D ball. Here's my build directory. Didn't do anything yet. Okay. Oh no, it's stuck. Oh, it's still going. Okay. Halfway there. Almost done. Yeah, it takes a hot minute to build usually. This is one of the complaints that people have with Unity, though, is that when you export, you get the entire Unity framework with it usually, and that can bloat your applications. So if you're an Android developer, for instance, and you build your project in Unity, you might notice that your simple Hello World application is like a gig of space. It's probably because everything came with it. So if you're doing stuff like that, there are ways to strip down what's actually built into your executable. Come on, we're 2/3 of the way there. Please finish before it's too late. I've got a contractor coming over tonight. My poor graphics book, it got all wet earlier. All right, are you done yet? We might have to do this next time. Well, what we'll do is we will start with this next time because this is going to take forever, it looks like. What the next step is I'm going to go into this folder and I'm going to run a Python web server. And that'll be my host. When it's done building, I'll have that. But since this is going to probably take another solid 5 to 10 minutes on my computer, we'll do this next time. Anyway, see you all Thursday, everybody. Look for announcements from me on Blackboard. And that's it for Unity 3D. We'll do 2D next time and shader graph after that. Bye-bye.